Okay, so number 18 here, let's go through the list. Okay, we've got to start with factoring. We always start with factoring. So the numerator does not have a GCF. So we just jump into x plus 4 times x minus 1. Okay, x plus 4 times x minus 1 is in the numerator. The denominator, we do have a GCF, so since I'm kind of limited on space, I'm just going to do that right below it. I'm going to take out the GCF. That leaves me with x squared minus 5x plus 4. Then I will factor the trinomial over here. Now be careful with this, because these are very similar to the factors in the numerator, but if you're not careful with your signs, then you will end up identifying something as a whole that should be a vertical asymptote and vice versa, okay? So be very, very, very careful with your signs when you're factoring something like x squared minus 5x plus 4. Okay, they have the same signs, they're both negative. Negative 4 times negative 1 is positive 4. Negative 4 plus negative 1 is negative 5. Okay, all right, so now that we have factored it fully, we can start with seeing if anything cancels and finding our other characteristics here. So, what cancels? X minus 1. So we do have a hole. We do have a hole at x equals positive 1. But this is going to be a point. We need to find the y coordinate as well. So I'm going to show you how to do it algebraically, and then I'm going to show you how to confirm it on your calculator. So what we're going to do is we are going to plug 1 into the simplified version. So this is what we are left with after we cancel the x plus 4 over the 4 times x minus 4. We're going to plug it in for x there. So I've got 1 plus 4 over 4 times 1 minus 4. So we've got 5 over 4 times negative 3, so negative 12. 1 is the x. The y is 5 over negative 12, which I don't know what that is as a decimal. Negative 0.4166. So we can plot our hole, since we know the y, x and the y, we put an open circle where that's supposed to be. So at positive 1, negative 0.4, and mine's not in a very good spot there. More like right there. Okay, put an open circle right there on your graph. Okay, so after holes, we look for vertical asymptotes. Vertical asymptotes come from what's left in the denominator. Okay, we were left with 4 and x minus 4 in the denominator. Well, 4 can't equal 0, but x minus 4 can. And that happens when x equals positive 4. So our vertical asymptote is at positive 4. And remember, just to kind of help us remember, I go ahead and label that VA down there at the bottom. Okay, x-intercepts. Those come from the simplified numerator is equal to 0. So we were left with x plus 4 in the numerator. So x equals negative 4, or the point. X-intercepts are points. So negative 4, 0 is our x-intercept. Now, I didn't have it on our list of things, but we need to talk about the y-intercept as well. How do you find the y-intercept of any function? X is 0, right? Because when you're on the y-axis, x is always 0, so you plug in 0 for x. So if we plug in 0 for x, you can do it in the original, you can do it in the simplified version, doesn't matter which one. But when we plug in 0 for x, we're going to get negative 4 over 16, so negative 1/4. So about right here, our y-intercept. And then the last things are horizontal asymptote. So horizontal asymptote, what's the degree of the numerator? Anybody? What's the degree of the numerator? Look at the original. What's the degree of the numerator? 2. It's the biggest exponent. Okay, I'm not trying to trick you. It is that easy. Okay, what's the degree of the denominator? 2. So they're the same. So it's the ratio of their leading coefficients. So the leading coefficient in the numerator is 1. The leading coefficient in the denominator is 4. So this horizontal asymptote is the same as number 17's. It is at y equals positive 1/4. Okay, so let's go to our calculator now and confirm all of this stuff and graph it. Okay, so we need to type the original, making sure we put parentheses around the entire numerator. I'm going to say that until you're tired of hearing it, and hopefully until you actually remember to do it, because inevitably somebody somewhere down the road is going to forget to put parentheses around the numerator and or the denominator, and it's not going to give you the correct graph. Okay, so parentheses around the numerator, parentheses around the denominator. I'm also going to put the simplified version in here. Parentheses around the x plus 4 divided by parentheses around the entire denominator. So in front of the 4 and then around the x minus 4. Okay, so make sure your parentheses are right. Okay, second graph. I want to look at the table first. Before I look at the graph, I'm going to look at the table to make sure that everything that I've written down so far is correct. All right, so my y values match, so I know that I factored and simplified correctly. Okay, I can confirm my whole when I go to x equals 1. I have an error in y1, but in y2, look at that number right there. That was that negative 5/12 that we found. Okay, so your calculator will actually tell you the y value if you plug in the simplified version, just FYI. We had a vertical asymptote at x equals 4. It remains an error in both because we didn't get rid of that problem. That problem was still there in the simplified version. We can confirm our x-intercept at -4, the y values are 0. We can confirm the y-intercept at 0, the y values are -0.25, -1/4. Okay, we can't confirm the horizontal asymptote with the table, but then we can look at the graph. Okay, and we can see it kind of looks like it appears out of nowhere. That's just because the calculator can't graph in that great of detail. So we need to go in here and we need to fill things in. Okay, we need to go through our x-intercept, go through our y-intercept. Don't go through the whole. Okay, stop drawing, pick up on the other side, get really close to that vertical asymptote. And then this other piece over here, if we wanted to, we could get, let's get one more point over here. Let's go back to the table. Let's see here at 5, it's 2.25. And at 6, it's 1.25. Okay, so just giving myself a few points to go through. And then again, trying to hug up to my asymptotes there. All right, now, the biggest favor you can do to yourself when you're working on these problems here in a minute is to do this in the exact same order every single time. Just make it a methodical process that you go through. I've tried to go in the same order every time so that it's just a list you're running through in your head. I factor, I simplify. Simplifying leads me to wholes. After I've simplified, then I can talk about vertical asymptotes and x-intercepts. And then at the very end, I'm going to go back and I'm going to do my y-intercept and my horizontal asymptote. Okay, so keep that process the same. It's going to help you remember all these pieces better, I promise. Okay, let's look at one more. Let's look at number 19 because it's got something that people tend to overlook here in number 19. So I want to cover that. And then I'm going to give you plenty of time to practice with these so you can get good at it and you can get used to what these functions are supposed to look like. Okay, number 19. What do we need to start with factoring in the numerator? GCF of x. We are left with x squared minus 16. Will that factor further? Yes. Difference of perfect squares. Y'all got to recognize that. They love to use the difference of perfect squares. You've got to start recognizing that as x plus 4 times x minus 4. Okay, denominator. What should we factor out of the denominator? A -4 and x. Okay, a -4 and an x. We are left with an x And you can't forget to add a 1. Okay, you got to hold the place. If you take that term out, you got to hold its place in there. You don't put that plus 1, when you multiply it back out, all you're going to get is the negative 4x squared. You lose your minus 4x. Okay, and that's as far as that'll factor, so I'm just going to bring that over here under what I've already factored for the numerator. Okay, does anything cancel? Linear factors, no. We don't have any linear factors that are the same in the numerator and in the denominator. Do our GCFs share anything in common? Yeah, they share an x, okay? We can cancel that x right there because it's a factor, all right? Because it's a factor. It's not x plus something or x minus something. It's just an x as part of the GCF, so we can cancel those out. So we have a whole at x equals 0. We need to find its y value. So when we plug in 0 into the simplified version, we get 4 times negative 4 in the numerator, so that's negative 16, divided by negative 4 in the denominator, so negative 16 divided by negative 4 is 4. Okay, so our whole is at 0, 4. We'll confirm that in the calculator here in a minute. All right, vertical asymptote. Do we have one? Do we have anything left in the denominators that equals 0? Yes, we have x plus 1. Oh, we're super quiet today. So x equals negative 1 is our vertical asymptote. I really need to calibrate this. There we go. X equals negative 1 is our vertical asymptote. Okay, what comes after vertical asymptote? X-intercept. Okay, we take what's left in the numerator, set it equal to 0. We have 2 factors left in the numerator. So we have 2 x-intercepts, negative 4, 0, and positive 4, 0. It is possible to have more than one x-intercept. It is possible to have any combination or lack thereof of any of these characteristics. Okay, after x-intercepts, we've got y-intercept. So we plug in 0. Oh, but wait, we had a whole at 0. If you have a whole at x equals 0, you're not going to have a y-intercept because that's a whole. All right, and last thing, horizontal asymptote. What we got? None. The degree of the numerator is greater than the degree of the denominator. We've got cubed in the numerator. We've got squared in the denominator. So numerator is bigger is none. Numerator is greater is none. So let's confirm. Okay. Get some practice typing this into your calculator. Numerator in parentheses of the original divided by denominator of the original in parentheses. Okay. In y2, put parentheses around the entire numerator plus the parentheses you already had in there. So you need parentheses, parentheses, x plus 4. Okay, notice how I have the little parentheses here were already there. I need parentheses around the whole thing. Divided by, I need parentheses around the whole thing in the bottom. Negative 4 parentheses x plus 1. Okay, parentheses are super important when it comes to these rational functions. Okay, go to the table first. Make sure your y values match up. So we're good. We are good. Our y values match up. Let's confirm our whole. We have an error in y1. We've got 4 in y2. That's what we said the y value was. So we're good there. Let's confirm our vertical asymptote. At negative 1, error, error, we're good. X-intercepts, let's confirm them. At positive 4, the y values are 0. At negative 4, the y values are 0. We do not have an y-intercept, again, as I mentioned before, because y1 has an error in it. It's a whole. It can't be your y-intercept. because it doesn't actually cross the y-axis because it's a hole right there. Okay, and then finally we can look at the graph to confirm whether or not we have a horizontal asymptote. Now this one's a little bit harder to do, but notice this graph does look a little different than the graphs we've been looking at. Most of them kind of disappear because they level off to the horizontal asymptote or into the x-axis. They kind of disappear. This one doesn't. Okay, the left side and the right side are continuing to increase and decrease. So we do not have a horizontal asymptote. If you wanted to add a little bit more detail, you're welcome to get values off the table, but I'm just going to go and fill in here. Hug my vertical asymptote, go through my intercepts, go through my hole, but don't actually cross through the hole. Make sure you leave a gap there. Okay. And make sure that it's obvious that my ends aren't leveling off, that they are continuing to increase and decrease. Okay. Okay, so do y'all want me to do one more, or do you feel like you need to practice some? I can do either one. Y'all want to see another one, or y'all want to try a few? I think y'all are scared to say anything. All right, let's try number 20. Okay, y'all try number 20. I will give y'all a